Hi guys, welcome back to our exercise number 5 video installment series. This is video number 4. So far we've gone through the process of creating a production plan for this particular part that involved building an operation list with the required number of setups. So we have 3 setups required. We're down here on the right in Excel. We've identified which toolpath types, which Mastercam toolpath types we're going to use to actually machine this part. From that operation list, we generated a tool list where we looked at the numbers, the depths of cut, and the operation requirements, and developed a tool list, proper tool, outside diameters, tool types, number of flutes required, the length of cut of our tool to clear material here, so we have reach concerns. And then we used Excel to calculate our RPM and our feed rates based on the defined surface speed and chip load. Then we came into Mastercam and we imported our solid model. And once we imported our solid model, we created the necessary planes or the necessary work offsets or coordinate systems to machine this part. So we have op1, which is associated with our top plane. XY 0 is on center, Z0 is top of part. Then we have setup number 2 work offset. So our G54 for setup number 2 is the bottom right corner of our part. Z0 is again the top of the part. And setup number 3, we flip the part over, and we're using the bottom right corner with Z0 being the top of the part. Then we proceeded to set up our machine, where we chose a program number, set our overrides, set up our stock, which you can turn on by hitting the display button right here. Or you can turn on by hitting the display stock button in your Toolpaths tab. Go back to my top plane. After we chose a machine and created our tool and stock settings here, we created the setup requirements, the toolpath group requirements that we need to execute our 3 operations. So we have 3 distinct toolpath groups, all of which are contained within our machine. So we're only using one machine, and we have 3 toolpath groups in that machine. Once we set those up, we proceeded to open our tool manager from our toolpaths tab. So toolpaths tab, tool manager, and we used our tool library, which is this bottom list of tools that we can filter using the filter options. And then we populated our tool list. So the window above is our current tool list. All these tools will now be available to us within our toolpath parameters tab. And we're going to see that today. So in this installment, in installment number 4, we're going to start applying toolpaths to this piece of material. So let's have a quick look at our operation list. Step 1, high-speed 2D dynamic milling toolpath to remove the bulk material. So we'll do that. Then we'll do a contouring toolpath to remove the stock that we leave on the walls of our part. That's this wall here and this wall. Then we'll cut this bottom pocket, this cross-shaped pocket with a 1/4 inch long reach end mill. Then we're going to do spot drill, drill, and tap of the 2 small holes here. And then we'll spot drill, drill, and tap, or spot drill and drill, my mistake, the 1/2 inch holes. So I'm going to breeze through this. I don't want this to take too long. So I'll try to be quick, and we'll probably end this series at the end of setup 1 and have a separate video for setup 2 and 3. Or I might splice them together into one video. I'll see how long this goes. Okay, 2D dynamic milling operation. So first thing we have to do is chain this. So we're going to choose a machining region, and then we're going to choose an avoidance region, and then we're going to choose a machining strategy. We all know how to do this. So our machining region, we're going to choose that based on our wireframe geometry. We're going to choose C-plane as opposed to 3D. What C-plane does is it limits our selection choices to a plane that's parallel to our working XY plane. So just to do this again, we're going to make sure we're in wireframe, not solids. We're going to choose C-plane so that our selection stays parallel to our working plane. We're going to make sure we chain as opposed to single entities, so full chain, and we'll select down here, and you can see it grabs the full perimeter. We hit OK. Our avoidance regions. Now we have to think about what we don't want our tool to cut, whether it's during the entry, the exit, or what have you. So we're going to choose our solids selector now. And here there's a few options. So you can pick edges, you can pick loops, you can pick partial loops, linked edges. We're going to choose faces. So we're going to select our faces, and the faces that we want to not machine is this face, that face. Let me do that again. 1, 2, 3, 4, and 5. So we're going to avoid these areas. And again, we're going to approach from the outside. So what do we like to do after we've chained something, especially where we're choosing regions, is we want to preview. Always preview. Let's have a little bit of a look here at what we're looking at. So I've talked about this in class. The red and green and black region is the region that will be machined. That's your machining region. Okay? The yellow, thick yellow lines are lines that your tool will not cross. So they're hard boundaries, they're walls. So you have a few sets of walls here. You have walls that are now protecting your remaining material, which has been defined by your avoidance region. And you have walls that are preventing your tool from moving too far past your machining region. Now this blue area is the area that you're deciding is safe for your tool to enter. So it can plunge in the blue area without any risk of plunging into material. Now, if you were to have chosen stay inside, if you forgot to choose an appropriate machining strategy and you preview this, again down here, you can see that your toolpath limitation, so this yellow wall boundary, is based on your machining region because you're staying inside of that. Now, obviously, your tool can't get into these corners, so it can't completely machine this material away. So you need to approach from the outside. So this is what we would like our chaining preview to look like. We have a safe area for entry, we have access to our machining region, and we're protecting our areas that we do not want machined, that we want to avoid cutting. Okay, tool. What tool are we going to use? The 1-inch end mill. As you can see here now, we have our complete tool list already populated. We can select from these tools as we move forward. You can see the appropriate tool numbers are already populated, including the length and diameter offset numbers. Tool geometry information is already populated, and your speeds and feeds are already populated. So no need to override values here. Unless, of course, you're plunging into your material, in which case you want specify an appropriate plunge rate. So the cut parameters that we should modify here, well, we don't want to leave any stock on the floors. We do want to leave stock on the walls, maybe 10 thou, that we can come back and finish with in our contouring operation, which we decided we wanted to do here, finish the walls. Approach distance. This approach distance is important. So you see this little red line. How far away from the boundary of our machining region do we want our tool to approach from? So currently it's 0. That means our tool will approach tangentially to our machining region. Let's give a little bit of space there. Maybe 1/8 of an inch. That way if our stock comes in on the plus side, so a little bit larger than expected, we will not plunge into material. Depth cuts. Well, what should our max rough step be? If we stick with our convention of limiting our axial tool engagement to 45% of our tool diameter, we can say that we have a tool diameter of 1 times 0.45, which is a 0.45 inch axial maximum rough step. We don't need to leave roughing finish cuts. We've already allowed stock to be left here for a finishing operation. We want that to happen in a separate operation. If we wanted finishing to occur with the same tool in this particular tool path, we would leave stock here, but we do not want that. Our entry motion, in our case, this is irrelevant. Why? Well, we have non-material areas for our tool to plunge into. So it will enter outside of the bounds of our machining area. If we go back up to our toolpath type, preview that chain again, here we can hide our dialog. You can see we have areas. All of our blue areas are safe areas for our tool to plunge, not hitting any material. Therefore, we don't need a helix or a ramp or a profile entry. There's no breakthrough required because we're not going all the way through our part. Linking parameters. I'm just going to turn my preview off there. Linking parameters. Okay, so first things first, everything should be an absolute. Top of your stock is currently at Z0. The depth that we are cutting to, we can look at our drawing, which is smart, or we can choose our model as a depth defining element. And to do that, we can click this depth button right here. I click that. Now I have the ability to grab geometry that is at the depth that I'm concerned about. So if I click that geometry, it populates this field with that Z depth. My feed plane and my retract plane, for the purposes of this course, are going to stay at 0.1 of an inch above my stock. And my clearance plane will be 1 inch above my stock. I'm going to turn my coolant on, and I'm going to create this tool path. Now, one thing I haven't talked about here is the fact that we are using a dynamic milling tool path. So the parameters I put are based on a non-dynamic milling tool path. Now, as we discussed in class, dynamic milling ensures that there is constant chip load, that there's the same area contact between your tool and your material at all times. Therefore, and only in dynamic milling tool paths can we increase our maximum rough step and use more of our flute length per pass. And the rule of thumb we discussed in class is 1.5 times D. So we have 1, which is our diameter, times 1.5. 1.5 times D. So we have a 1.5 inch maximum rough step. And our step over, therefore, needs to be small. We're not going to use 45% or 50%. We're going to use something small. Even 25%, in my opinion, is high. I might use 15%. So 150 thou radial step over with a very high maximum rough step. So we're using more flute length with less radial engagement. More axial engagement, less radial engagement. So let's update this toolpath and see the difference. Now we can backplot this. We have fewer steps. 1, 2, 3. So I'm happy with that. Let's move on to our finishing the walls, our contouring operation. So this is actually a really good example of something I forgot to do. So you have your little red indicator here that is telling you, they call it an insert arrow. It's telling you where you're going to be placing whatever task you're working on. So I forgot to put my arrow, insert arrow up in setup number 1. I've currently created this particular toolpath in setup number 3. See that? So I need to drag that up and drop it into setup number 1. And then I'll make sure that my insertion arrow is now in setup number 1 for the rest of this particular programming job as it relates to setup number 1. So back to our contour. We're going to create a contour toolpath. Now what we want to do is choose wireframe as opposed to 3D. Again, we can choose C-plane, and we're going to do single entities this time. So we want to grab this line here and that line there. So we have those two lines or chains. Let's just go back in and have a look at what this looks like. And you can see it defaulted to not only the wrong side, but the wrong direction. If I want to climb mill this face, I need to be entering from the other side. Additionally, I need my arrow here to be pointing in. So I'm going to come back to this. I'm just going to turn this toolpath off in my for my first toolpath here by putting a green check mark on the folder and toggling the toolpath off. Now I'll go back in and fix this geometry. So I'm going to right click and reverse this chain. So I start here, end here. I need to take the other one and reverse that chain. So I'm climb milling on this side and I'm climb milling on this side. My arrows are pointing in, so I know I'm machining on the correct side. So that geometry is now good. I'm going to go into my parameters, select the tool. I want to use the 3/4 inch end mill. I'm not going to leave any stock. That's the point of this toolpath, is to remove the stock that was left in the previous operation. Depth cuts. I'm going to choose an appropriate maximum rough step. Now keep in mind, I'm only removing 10/1000ths of an inch of material, but nonetheless, I'll stick with my convention of 0.75, so that's diameter, times 0.45, which is 45% of my diameter, which gives me a 0.3375 maximum rough step. And again, it's going to divide the amount of distance into equal components, which will result in some number less than this, but this is the maximum I will allow. My lead in and my lead out. So I want to disable my entry and my exit. And then I want to enable my adjust start of contour for both entry and exit. And I'm going to make this adjustment 100% of the diameter of my tool. So 0.75 inches. I will extend my straight line tool path, extend, and then at the end of the contour, I will extend by 20%, just so it comes past the tangent point. There's no breakthrough because I'm not going all the way through. There's no multi-passes because this is a finishing operation. My linking, again, I have the same Z step from the previous operation, which is minus 3.25. And remember, I can click my depth button and grab that number from my model. Top of my stock is 0, 0.1, 0.1, and 1. Coolant is on. Turn this toolpath on. And you can see I have my, if I look at this from the top, my toolpath has extended on the entry side by 100% of my tool diameter, which gives me quite a bit of clearance. I actually really only need 50-60%, something over 50%, and then a little bit of an extension to make it all the way through on the other side, and then entry, exit. So I have my bulk material removed, my walls are finished. I'm going to cut this pocket down here with my long reach 1/4 inch end mill that we defined in video number 3, which is up here. Now this is a little bit of a ridiculous length, but it is what it is for this particular exercise. My insertion arrow is in the correct place. I'm going to toggle my toolpath off so I don't have to look at it. And let's create a pocketing operation. I'm going to turn my C-plane on. I'm going to choose full chain. I'm going to zoom in here. I'm going to grab the bottom. So it chains all the way around. The tool I choose will be my 1/4 inch long reach end mill. If I'm not sure which one of these is the long reach end mill, I can double click in here and look at my tool geometry. 5 inch overall length, cutting length 3.5. That's the one I want. And a climb mill, standard pocket. I don't want to leave any stock. I'll choose a parallel spiral with a 45% step over, 45% radial tool engagement. Now I want a helix in. Again, 45%. Clockwise helix. No finishing passes. And I can enable a finishing pass if I want, but for this exercise we won't. I don't need a lead in or lead out. Don't need depth cuts. My linking parameters, I'm absolute across the board. Top of my stock will be this 0. So let's talk about top of stock here. So the top of stock will be this surface here. My depth will be this bottom. My feed plane and my retract will be above the top of my actual material, and my clearance will be 1 inch above that. Coolant is on. That's my toolpath. So what's next? We need a drill, spot drill, drill, and tap. These small holes, spot drill, drill, tap. And then spot drill and drill these 1/2 inch holes. So let's create a drilling toolpath. We'll do the small holes first. We're going to choose our spot drill. We're going to choose a drill counterbore cycle. We're going to enable absolute across the board. Top of the stock again. This is the top of our stock. Retract will be 0.1 above our physical stock. Clearance 1 inch above the physical stock. Our depth, we're going to use our calculator to calculate the depth, giving us a 50 thou additional diameter or 25 thou on the radius chamfer. So remember, overwrite the depth and determine what the finished chamfer diameter should be. So we have 0.375, which is the OD of our tapped hole, plus 0.025 on one side, plus 0.025 on the other side. 0.425 is the finished diameter. We can hit OK, and you can see it specifies the required depth. There's no tip comp because we're not going all the way through, and we're going to turn our coolant on. Here's our toolpath. I'll just turn this toolpath off, as I will that one, by clicking on the folder that you want to control the visibility of. Now, instead of creating a whole new cycle, I'm just going to highlight that, Control C, Control V, which is a cut and paste operation. And then from there, I can just modify the parameters. My geometry is still good, it's the same holes. My parameters will be my tap drill, so my 0.313 drill, my 5/16 drill. Cut parameters this time will be a peck. We're going to peck drill through this hole. Our linking parameters, we have the same top of stock, the same clearance, the same retract, but we have a new depth, and that depth will be based on going all the way through. So we can click some geometry on the other side and it populates this field here for us. Now, in order to ensure that we get the whole tip through, not just have the point of our tool end at the surface, we're going to enable tip comp and then give an additional breakthrough value of 0.025. Coolant's going to come on, which it already is, and we're going to hit OK. So we have spot drill, drill. Now we're going to copy and paste the pectoral cycle, Control C, Control V. We're going to modify the parameters, choosing our right-hand tap, giving an additional breakthrough, 1/4 of an inch to allow for the lead in of our tap. Our linking parameters stay unchanged. Coolant's on, and we're good. So we have a drill, a spot drill, a drill, and a tap. Oh, we forgot to change our cycle in our tap toolpath here. So let's go to our cut parameters and choose tap. And remember, save often. Save is your friend. So now what's left? We need to spot drill, drill these 1/2 inch holes, and that will complete this particular operation. So we're going to choose the spot drill and the drill. Control C, Control V. I'm going to delete those, do that again. I want my spot drill and my drill. Control copy, Control paste. So we have our drill counter bore now and our pec drill. The drill counter bore, all the parameters should be good except for our geometry, which we need to reselect. So we'll right click in here, delete all, and choose those two holes. And then our parameters need an adjustment in our linking by using our calculator to calculate a new depth to achieve our chamfer. So the hole diameter is 0.5, plus we want to add 0.025 on each side of that hole to get our proper chamfer. And now we will change the parameters of our pec drill cycle. We'll select the tool that we need, which is the 1/2 inch drill. Our tip comp's good. Our linking's good. Our coolant's on. We're good. So I have 1, 2, 3, 8 toolpaths required to do Op1. We can simulate this now. If we want to simulate all of our toolpaths in setup number 1, we need to enable them all. So we can select all operations. You see green check marks on all of our operations now. Let's go ahead and click the verify button here. Make sure this makes sense. Speed things up a bit. So 1 inch end mill, 3/4 inch end mill, super long 1/4 inch end mill, spot drill, drill, tap. Looks like we have an issue with our 1/2 inch. Let's go double check some of our parameters. So we'll check our drill counter bore, spot drill, 5/16 drill, and then the 3/8/16 tap. And then we'll select all and get rid of all of our tool paths. And then we'll check our 1/2 inch drill here. Linking parameters -4. You can preview that. We forgot to change our geometry for our 1/2 inch. So let's go do that. Toolpath type, choose our geometry, right click, delete all, choose these other two. Hit OK. Hit OK. Clean that toolpath. Then we're good. Save. Okay, that's setup number 1. Video number 4. Exercise number 5. How's that for a bunch of numbers? Let's have a close look at that process. There's nothing complicated here. There's a few new things that we looked at. I will follow this up. I'll probably just actually splice setup number 2 and number 3 onto the tail end of this. So don't go anywhere. We're going to continue with this in a second here. Hi folks, welcome back. If you've taken a break, I did. Anyway, where we left off was we have completed setup number 1. So all the toolpaths necessary to machine from this orientation are now complete. That includes removing the bulk material, finishing the side faces, cutting the cross-shaped pocket, spot drilling and tapping the tapped holes, the 3/8 tapped holes, and then spot drilling and drilling the 1/2-inch holes. Now we're going to move on to setup number 2. So as you remember, we already have a coordinate system, a work offset for setup number 2. We will enable it. Look at it from that view. And make sure our insertion arrow is down in setup number 2. We can close the folder for setup number 1 if we don't want to look at that. And we can think about what happens next. Let's look at our operation list. Let's look at our plan. So we need to pocket the triangular pockets. And then we're going to contour these radii. So let's go ahead and do that. So we'll choose a pocketing operation. Now we're going to choose C-plane, wireframe. We're going to chain entire regions. So there's 1, flip, 2. I think we need to change the direction of the first one. So we can go back in. We want to climb mill this, so we want to reverse chain. So now we're climb milling both of these. The tool we're going to choose is our shorter, not our long reach, but our short reach 1/4-inch end mill. Make sure we're climb milling. We don't want to leave any stock. We'll do a parallel spiral toolpath, 45% step over. Now we are entering into material. We're not entering into the air, so we definitely want to enable our helix entry. Depth cuts should be 0.25, which is the diameter of our tool, times 0.45, 45% of our tool diameter. Breakthrough. Now our tool is going all the way through. We can enable breakthrough and add a little bit of an extra value on here to make sure that we cut with the full shank of our tool. Oftentimes you might have a corner chipped away from your tool and you don't want to have a little burr left on the bottom. Sometimes if you're cutting softer material like aluminum and you try to end at the bottom surface and the surface has 5 or 6 thou of stock left on it, you might have pop can thickness of material left on there. So let's have a 10 thousandths or even a 20 thousandths or 25 thou breakthrough. Linking parameters. So the top of our stock is currently at Z0. The depth of our cut we'll grab from our solid model. Our feed plane and our retract should be 0.1 above our stock, and then our clearance plane 1 inch. Coolant should be on. We hit OK. You can see the helical entries here. You can see our radial steps and our axial steps. Now let's cut. Let's contour our fillets. So we'll choose a contouring toolpath type. We'll choose single entities for our chaining. Whoops. And we'll choose 1, 2. We can go double check those. Pointing to the outside, we're starting and stopping in the right locations for climb milling. We'll do this with our 1/2" end mill. Not going to leave any stock. Let's limit 0.5 tool diameter times 45%. We'll look at our lead-ins. So I'm going to hide my panel here. Can look at this from the top. Can bring it over, hit escape to re-enable my panel. So we'll do a lead in and a lead out. We'll use arcs, arc entry and arc exit. So we'll use 0.25, maybe 50% of our tool diameter, and then a line of, say, 25% of our tool diameter. We'll hit this arrow to apply the same entry and exit parameters to our exit. We're not going to keep our start of contour adjustment enabled. We enabled these on a previous toolpath and it remembered that. Breakthrough, we can enable 0.025 for the same reasons as we discussed on the last toolpath. Linking, absolute across the board, 1.1, 0.10. Again, this depth will be taken from our solid. Coolant should be on. We hit OK. So that's setup number 2. I'll select enable all toolpaths, cycle them on, cycle them off, so I don't have to look at them. And then I can move on to setup number 3. So I got to move my insertion arrow down. I can close setup number 2. And I can go to my planes tab and enable my work coordinate system for number 3. Okay, we're going to do similar pocketing operation here. Circle milling operation. Or this can also be done as a pocketing operation, but we'll do it as a circle milling operation because that's what our plan tells us. So I have a pocketing operation from the other side that I'm going to reuse. Control, copy, control, paste. But there's a few parameters that need to be changed. Firstly, I'm going to go down to my planes, and I have to change my working plane to setup number 3. I do that by selecting my work coordinate system selector dialog here, find setup 3, hit OK. And I do that to my tool plane, and I do that to my construction plane. So all three of my planes are setup number 3 now. While I'm down here, I'll look at my coolant. Yes, it's on. My linking parameters should all be good since this part has some symmetry in terms of the depth. Breakthrough should be unchanged. That should be unchanged. I will need to select new geometry though. So let's rechain this. Rechain all. So I right click, rechain all. So I have to make sure I have my, I'll unselect what I just did. Make sure I'm wireframe, make sure I'm chaining. I'll choose C plane so that I limit myself to planes that are parallel to my construction plane. And then I'll select this contour. And that should be good. If I want to see what that looks like, I can just enable that. Toolpath toggle. Circle mill the hole. Well, let's choose circle mill. Grab that hole. I'll use my, sure, let's use the 1/2-inch flat end mill. Why not? No stock. Turn the stock off. Enable roughing. I want to have a helical entry with 45% of my tool diameter. Not leaving anything for finishing. Depth cuts should be 0.5 times 45%. Breakthrough can be enabled. 25 thou. 0, 0.1, 0.11. And my depth will be, again, minus 0.5, which I selected from my model by clicking on the depth button. Coolant on. Done. Now what do I have left? I've done my pocketing of my triangle. I've contoured. I've circle milled the hole. I need to contour the fillet. So I'm going to grab from my setup 2 this contour toolpath, Control C, place it in my setup number 3, modify some parameters. Well, firstly, the planes need to change to setup number 3. Setup number 3. And then my chain. So I'm going to rechain all. Choose single entity. I like the direction. Happy with that. And that should be good. So if I want to have a look at that. I can make sure that makes sense, which it does. You can see my breakthrough is enabled. Now what I have left to do is to spot drill, drill, and tap these holes. And I'm done. So spot drill, drill, tap. I'll select these 3 operations. Control copy. Make sure my insertion arrow is in the right place. Control paste. I'll go in, close this other stuff up, and I have to change a few things here. So I'll go change all the planes, and then I'll change all the geometry. Planes, set up 3, set up 3, set up 3, delete all. 1, 2, 3, 4, 5, 6. And that should be good. The only thing I need to do here still actually is go to my linking, and I need to adjust the depths. So top of my stock is 0, and the depth will be based on 0.375 plus 0.05. Yep. That's good. Everything's still good from the previous. Our pec drill, we'll change those parameters. So again, change our planes. Make sure we're working in setup number 3. We'll go up to our linking parameters. Top of our stock's at 0. The depth of our drilling operation will be based on that bottom surface, minus 0.5. Tip comp is fine. Our point geometry can clear. And then copy previous points. Hit OK. Clean that toolpath up. And then now our tap parameters. Planes. Change those to setup number 3. One more. Again, everything is the same as it was in setup number 1. None of this needs to be changed except for our linking, which top of stock is 0. Our depth is minus 0.5. And we'll reselect our geometry. So clear the previous geometry, and then choose this little arrowed button here, which is copy from previous. Now if I choose 1, 2, 3, backplot those. Hit save. That should be all of our operations. Now we can simulate this and verify it. So we'll select all operations. You can see that they're all selected, green check marks across the board. Hit verify. Speed this up. This will take a few minutes. I'll actually slow the speed down once it gets through this dynamic milling operation here. Finishing. Machining of the pocket, spot drill, drill, tap. Pocketing. Pocketing. Contouring. Pocketing. Circle milling. Contouring, spot drill, drill, tap. So we have appropriate chamfers on our holes. Appropriate chamfers on our holes. This part is complete. So we have a few more steps we need to do here before we end this video. Machining's done. Our machining strategy has been executed. Now we need to prepare this program. I'm going to save just to be sure. We need to prepare this program for posting. So we're going to clear all operations and we're going to shift select just setup number 1 operations. See the green check marks here? Only the operations in setup number 1. Then we right click on our setup number 1 toolpath group. And then we're going to edit those selected operations and change the NC file name. We'll call that X5. Let's just call it setup number 1. And we're going to select setup number 2 operations. Right click, edit those, change those to setup number 2 or operation 2, whatever you want. And then we'll grab all the operations from setup number 3 and call them setup number 3. So we've organized our work according to operations. We've renamed the operations to associate them with the appropriate NC file names. So the programs we're going to post will have names called setup 1, setup 2, and setup 3. We have all the toolpath types we need. We've systematically approached this project by creating a plan with our operation list and a tool list. We created the tool list and our tool manager all at once in order to be more efficient, and then we executed our plan. Most of the thinking was done up front. So I highly encourage you guys to practice this exercise if you can get access to Mastercam. If not, study these videos, watch them 2 times, 3 times. When it comes to the exam, I'll post a description of what you can expect for the test. But this is your assignment for the next, well, for this week and next week anyway. And I will be posting a quiz that will quiz you on what you've learned here. So take the time, understand this process. Thanks for tuning into these videos. I know it's been a bit of a stretch, but we're all getting through this and learning together. So please stay safe and good luck.